All right, Algebra 2 people, here are your notes for the last section of the chapter where we are going to focus on writing the equation of your parabola. Hello, Algebra 2 people. Here are the notes for the last section of this chapter, 2-4. So this section is going to focus on how to write the equation of a quadratic. And we're going to be using sort of several methods, everything we've learned up to now. So the first one is given a point, which means you're given a particular xy, and you're given the vertex, which is your hk. You can write the equation. So of course, it's going to be in vertex form, which remember looks like y minus k equals ax minus h squared. And the idea is that you will plug in your xy, you will plug in your hk, and then the only thing you have left is solve for a. So that'll be one method. Another method is given a point, and again, we're going to go through an example of each of these. And given the x-intercepts, remember we were calling these R1 and R2. Since these are the intercepts, we're going to use the intercept method. And by doing that, remember this looks like y equals a x minus root 1 times x minus root 2. And the idea again is you're going to plug in your xy, and you're going to plug in your R1 and your R2, and again, solve for a. So there's going to be a common pattern to these. And then the one that's going to be new this time is given 3 points, whether it's from data or a graph. And this one, you're going to use your standard form, and it's going to require us to revisit solving a 3 by 3. So remember, standard form is y equals ax squared plus bx plus c. And you are going to solve a 3 by 3 after plugging in 3 different xy coordinates to solve for a, b, and c. Since you have 3 unknowns there, you need 3 equations. All right, so this is sort of our goal of what we're going to do. Now let's go through and actually do each one of these examples. So this first one is an example of the graph. Notice it gives you the vertex point, and here's a coordinate or xy on the graph. So what I recommend is you kind of identify what you have. So we have a particular xy, which is 0, 15, and I have a particular hk, my vertex, which is 50, 35. And we're going to plug in what we know into our vertex form. So here's your vertex form. And we're going to then plug in this given information. So y is 15, and k, here's my k, is 35. And that's going to equal a, which we don't know. X is my 0, h is my 50, and we square that. So we're going to go through and simplify that. That gives me negative 20 equals a times 50 squared is 2,500. So we can solve for a. Sort of divide through. So that is gone. We're going to cut out that 0, and negative 2 over 250 is reducible to 120, negative 1 over 25. That's my a value. And then you put it all together. So the equation should always have a y and an x in it. You're substituting for all of these variables So we know that it's going to be y minus 35 equals negative 1 over 125 x minus 50 squared. And that would be our final equation. Now this one also said, what is the height of the net when x is 90? So what you would do, I didn't give you a lot of room here to do this, I would plug in when x is 90 and evaluate the equation. And if you do that, you will find that y equals 22.2. So that's somewhere off the grid there. Okay, so that's how you would utilize the vertex form. Now let's go on and see the next example. So this next example is showing us a meteorologist creates a parabola to predict the temperature, and they're actually, notice, giving us the intercepts. I can't highlight the other one because my menu is in the way. Here we go. There are my two intercepts. So I have two R1 and R2, and they gave me this other point right here. So what I'm going to do with that is write down my given information. So I know that R1 is going to be 4, R2 is 24, and they gave us a particular XY value of 9.6. So I always recommend writing down your general equation. It's just a good reinforcement. So intercept form looks like this. Y equals a, x minus root 1, x minus root 2, and then fill in the given information. So the y value they gave us is 9.6 equals a. The x value is 0, root 1 is 4, and then 0 minus root 2, which is 24. And then notice the only variable I have to solve for is a. So 9.6 equals a, negative 4 times negative 24, which turns out to be 96. So if I divide both sides by 96, turns out that a is going to equal 1/10. And I don't care whether you give me a fraction or a decimal. Either one's fine. So then we can put it all together. That's all we had to do was solve for a. So once again, you want to make sure that you're only filling in the non-xy values, because you still want x and y in your final equation. So we have y equals 1/10 x minus 4 times x minus 24. That would be the final equation. Now this one also asked us, write a function f that models the temperature over time, which is what we did. What is the coldest temperature? So realize that the coldest temperature is going to be the minimum value. So that means we have to find the coordinates of the vertex. So the first thing we do is notice what is halfway between 4 and 24. So remember, to find the x-coordinate, you have to take the average of these. So 4 plus 24 divided by 2 is going to be 14. That's when the minimum happens. So to find the y value, we have to plug in 14 minus 4, 14 minus 24. So this simplifies out to be 10, negative 10. So the coldest is going to be negative 10 degrees Celsius. Okay? Okay, so as I said before, you're also going to be revisiting solving 3x3s, but these are all going to be the friendliest 3x3s you'll have to solve, because when you write out standard form, ax squared plus bx plus c. Notice that c does not have an x on it, which means it's always going to be a good candidate to eliminate right away. So this is how this is going to work. We need 3 points, so I always recommend taking the smallest 3 x values, and we're going to plug in the corresponding y and set up 3 equations in 3 unknowns. So you know how I like to label my equation. So the first one, my y value is 6. Now, the x value here is 0, so it's like plugging in 0 times a plus 0 times b, because x is 0, plus c. So this was a really friendly one because we know c right off the bat is going to be 6. Remember, c represents your y-intercept. So whenever you're given a 0 for the x, it's kind of like a little gift. You already know what c is. So now I'm going to write the second equation. The y value is 22 equals, the x value is 2, so I have to square that. So I'm going to have 4a plus 2b plus, instead of c, I know what c is, so I'm just going to plug in 6. And then for the third equation, I've got 22 equals, now my x value is 4, so 4 squared plus 4b plus, again, I'm going to plug in the c that is 6, since I already know it is. And so with these two, I'm going to kind of continue up here. We're going to simplify things. So I'm going to subtract 6 to the other side. So I have 16 equals 4a plus 2b. And this other one, I'll also have 16 equals 16a plus 4b. So there's many things I could multiply by something, but I tend to like to make things smaller. So what I'm going to do is I am going to divide everything here by -2. And so I have -8 equals -8a minus 2b, and we'll revisit, just write this one underneath. 16 equals 4a plus 2b. We can now combine those two equations so that we have 8 equals -4a. B's are going to go away. So we now know a is going to be a -2. And all I have left is to solve for b. So I'm just going to, doesn't matter, plug it in somewhere. 16 equals 4 times a -2 plus 2b. So this is a -8. So if I add 8 to both sides, I have 24 equals 2b, which tells me b is 12. And we still have to put it all together. So this means y equals, a is a -2, x squared, b is 12 plus 12x plus 6. So that is your full equation. That was not too bad. And then they did ask, find the height of the baseball after 5 seconds. So that's just plugging in when x is going to be 5. So -2 times 5 squared plus 12 times 5 plus 6. So you have -50 plus 60. That's 10 plus 6. So that's going to be 16 feet. Okay? All right, so there's 3 examples. Now, the other thing that's going to be kind of new is, given a set of data, what if you don't know? You have no idea what kind of equation the data represents. We have already seen linear data, because that means we have a constant difference between each term. But now, we're going to refine that. It's the constant first difference. So for instance, notice here I have +1, +1, +1, but when I look down here, I got -5, minus 3, minus 1. That's my first difference. Now, if this were constant, that would tell me this is a linear function, but that's not a linear function. So what we do is we take the difference again. Notice I get positive 2, positive 2. I'm adding positive 2. When you get a constant second difference, we know this is going to be quadratic. So think about it. Quadratics are something x squared. It's that 2 that goes with the second. If I didn't have a constant second difference, but a third constant difference, that would be a cubic function, and it keeps going progressively. Whatever your power is, that's how many differences it takes to get a constant difference. Okay, let's see how this plays out. So you're probably going to want to have a calculator handy if you're following along. So we want to find out what kind these are. They might be linear, they might be quadratic, they might also be neither. So we notice on top plus 1, plus 1, plus 1, so that's all good all the way across. This looks like, well, you're not adding something constant, and if you kind of look at the pattern, most people noticed right off, this is times 3, times 3. So it actually has a pattern, but it's not one of our addition patterns. So this is neither linear nor quadratic. Turns out, and it's okay if you didn't know this, it's actually exponential when you have an add multiply pattern like that. But all you have to tell me is that it's neither. So let's see what this next one will give us. So in this next one, we have plus 3, plus 3, plus 3. So that's nice. We have constant on top. Here we have minus 6, minus 6, minus 6. So that first difference is a constant difference. So this is your first difference. So that tells me this is going to be linear. And we can come up with the equation. So y equals my slope is going to be the rise over the run, negative 6 over 3. So that's negative 2. And notice they gave us a gift here. Whenever you're given x is 0, you're given the y-intercept. So I know my b value is 36. And if you're not sure, you can plug in some points and it should match the given data. So that's your linear equation. Now we come over here, let's see what this one gives us. We have plus 1, so everything's good on top. And we look at this difference down here. So this is going to be 416 minus, I always like to do it going backwards. You want to be consistent whichever way you're going to subtract. So this would give me a negative 8. 376 minus 416, that is going to be minus 40. 304 minus 376, minus 72. This one will be minus 104, I believe. And this one's minus 136. Okay, so obviously this is not linear because these are all different rates. So I keep going. If I go negative 40 minus a negative 8, so that's negative 40 plus 8, that's a negative 32. Negative 72 plus 40, because minus a negative 40, is a negative 32. Ah, look at this. When I subtract negative 104 minus a negative, I get negative 32, and voila, we get that constant second difference. That's what tells you this is going to be quadratic, and now we have to solve a 3 by 3. Notice I did not give you a gift this time. There is no 0, so we are going to go through the process, but you'll see these are also actually kind of friendly. So we're going to write down our A, B, and our C. So my y value is 424. So since x is 1, it's a times 1 squared plus b times 1 plus c. So So that's our first equation. Second equation is going to be 416 equals, now x is 2, so this will be 4a because x is squared there, 2b plus c. And my third equation is 376 equals, so 3 squared plus 3b plus c. And this is what I want you to notice. You'll always have nothing on your c value. So what I always do is I take the middle equation and I just multiply everything by -1. So what I'm going to do is I'm going to add a plus b, and then I'm going to add b plus c. So I'll have two equations that'll just be an a and b. So a plus b, that's going to be the first one. That's going to give me 424 minus 416, which is 8, equals -3a minus b, and the c's go away. Underneath it, I have -416 plus 376, which is a -40. 9 minus 4 is 5a. 3 minus 2 plus b. My c's are also gone. And notice I can also quickly get rid of my b because they're always going to be just one apart. So this will give me -32 equals 2a. So I know that a is going to be a -16. And then to solve for b, I can plug it in anywhere I want. I guess I'll plug it in here. So 8 equals -3 times a -16 minus b. So that's 48. 8 minus 48, -40, equals a -b. So b is going to be 40. And now to solve for c, we can go back to our equation a, which says 424 equals -16 plus 40, plugging in for a and b, and solve for c. So this actually simplifies out to 24. So if I subtract 24 from both sides, I get c equals 400. And now you're ready to just put it all together. So y equals -16x squared plus 40x plus 400. Yes, it still takes some work, but they all will follow this same pattern. If you just write down the three equations, let the middle one be negative, you can immediately get rid of your c values, and a and b should then come out pretty quickly. Okay? I hope that helped.